Welcome to Precalculus Concept 1A sequences. Today we're going to learn how to find particular terms of a sequence from the general term. There are 4 boxes, so let's get started right away. So let me ask you right away, what is a sequence? What do you already know about the word sequence? So a sequence is nothing more than just a bunch of numbers put together in a particular way. Let me give you a very, very famous sequence right now. It's called the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, and then so on. What do you think the next term would be right after the 13? Yes, 21, you guys would be correct, because all we're doing is simply just adding the sum of the 2 previous terms, right? So 1 plus 1 gives you 2, 2 plus 1 gives you 3, 3 plus 2 gives you 5, 5 plus 8, or sorry, 3 plus 5 gives you 8, 8 plus 5 gives you 13, 13 plus 8 gives you, of course, 21, and then so on and so forth. So when you see those 3 dots located right down there, that means that the pattern continues as you have previously established. So when you see those 3 dots, that's what that means. Okay, here's another really basic sequence. 1, 2, 3, 4, 5, 6, and then so on. Just counting numbers, the natural numbers in general, could be a sequence. So a sequence is nothing more than just a string of numbers put together in a particular way. The way that the book defines a sequence and the way that we're going to define the sequence is as follows. An infinite sequence, represented by these little curly brackets here, a sub n. So this is the notation that we're going to use. So a sub n is a function whose the domain is the set of positive integers. Now, I know that sounds kind of weird and scary, but let me explain it to you a little bit more. So take, for example, that Fibonacci sequence that we just did before, okay? So the very first term, which I've underlined here in green, this is going to be a sub 1. So the very first term is a value of 1. The very next term, a sub 2, is also a value of 1. The third term, a sub 3, is a value of 2. The fourth term, a sub 4, is a value of 3. So that subscript there is just a way for us to determine which term that we are talking about. And by the way, each of these pieces here, this piece, this piece, this piece, these are called terms. Each of these are called terms, the terms of a sequence, okay? So if I want to talk about the 5th term, then it happens to be number 5. If I want to talk about the 6th term, it happens to be the number 13. When it says here it's a function, it means that when I plug in a 1, I would get out a 1. When I plug in a 2, I would get out a 1 also. When I plug in a 3, I would get out a 2. When I plug in a 4, I would get out a 3. That's what they're saying. The domain is the set of positive integers. This is your domain, the 1, the 2, the 3, the 4, the 5, and so on. So the domain is the subscript, the little tiny subscript down below, and it consists of all the positive integers. Okay, here's box number 3. It says write the first 4 terms of the sequence whose nth term or general term is given. So I've got 2 examples for you, A and B. A says that in general, a sub n, the sequence can be defined as 3 times the number n plus 4. So we're going to write out the first 4 terms, 1, 2, 3, and 4. So set yourself up for success here. A sub 1, A sub 2, A sub 3, and A sub 4. Okay, how do I get the first term? Well, it's a function, so I need to plug in the number 1 right there for n and then evaluate. So it's going to be 3 times the number 1 plus 4. 3 times 1 is 3 plus 4. That's the number 7. So the first term of this sequence is the number 7. Let's do the second term. Plug a 2 in. So that'd be 3 times 2 plus 4. 3 times 2 is 6. 6 and 4 make 10. So the second term of the sequence is 10. Plugging in the third, I will get 3 times 3 plus the number 4. 9 and 4 make 13. And then finally the last one would be 16. So the first 4 terms of the sequence whose nth term or general term, that's this piece right here, this is the general term is given, would just be 7, 10, 13, and 16. Okay, let's try example B together. This one looks a little bit more interesting. It says a sub n is equal to -1 in parentheses raised to the n power, all divided by 3 to the n power minus 1. So again, we want to write out the first 4 terms, so set yourself up for success like I'm doing. So call this a sub 1, call this a sub 2, a sub 3, and a sub 4. So the first term I get by plugging in negative 1 raised to the first, all divided by 3 to the first minus 1. Then I need to evaluate this, right? Negative 1 all raised to the first power is negative 1. So, and then 3 to the first is 3 minus 1 is 2. So this is negative 1/2. This is negative 1/2. Does that make sense? I hope so. Plug in a 2. This is going to be negative 2, negative 1 all raised to the second power all over 3 to the second power minus 1. Negative 1 squared is a positive 1 because it's negative 1 times negative 1. 3 squared is 9. 9 minus 1 is 8. So this is a positive 1/8. Okay? Plugging in the third term, I would do negative 1 all to the third over 3 to the third minus 1. Negative 1 cubed is still a negative 1. So I'm going to have negative 1 over 3 to the third means 3 times 3 is 9 times 3 is 27. So 27 minus 1 is 26. So this is negative 1/26. And then finally, for the fourth term, I would do negative 1 to the fourth all over 3 to the fourth minus 1. So that would give me positive 1. 3 to the fourth is 81. 81 minus 1 is 80. So that'd be 1/80th. Okay, here you go. This is your first U-try. Write the first 4 terms of the sequence whose nth term or general term is given. Ready, set, go. Okay, well, hopefully you got the right solution here. For the first one, you should have had 7, 9, 11, and 13. And for part B, you should have had negative 1/3, 1/5, negative 1/9, and 1/17.